Well, review. We have a lot of ground to cover, so let's get to it. Instead of writing out all new problems, I decided it would be best to go ahead and look through the lessons where we will see a concentration of problems in our celebration of learning. Lesson 13 is a really good place to start that review. We talked about this in class today. You guys are really great at multiplying fractions by fractions. Just a few of us, including myself, might need just a quick refresher to support those answers with a model. Because remember, in our celebration of learning, we're going to have to find the answer, which you guys can see 1/2 times 1/5, 1/10 very easily, but we need to support this answer with a tape diagram. I'm sorry, not with a tape diagram, with some sort of model. Let's look at B here, 1/3 of 1/2 of a cake. You guys know that 1/3 looks like this. 1/3 of 1/2 of a cake. So we're looking at, initially, 1/2 of a cake. We're looking at 1/2 of a cake. But we want 1/3 of the 1/2. Okay, so here's our 1/2. And now what we need to do is we need to lay down thirds on top of our 1/2 because we're looking for 1/3 of 1/2. So we'll just go ahead and lay down 3 equal rows. We have 1/3, 2/3, 3/3. Can you guys see those rows here? Dink, dink, dink. We're looking for 1/3 of 1/2. So we're just looking for one row, 1/3 of the green. 1/3 of 1/2, or 1/3 times 1/2, is equal to, well, 1 times 1 is 1, 3 times 2 is 6, 1/6. Let's see, does our diagram, does our model support that? Yes. 1/2, I'm sorry, 1/3 of 1/2 is equal to 1/6. So yeah, we'll see a few of these. Hey kiddos, lesson 26 is another point of focus for your celebration of learning. In lesson 26, you will recall we divided fractions by whole numbers. So you're going to be asked to solve this expression or evaluate this expression, and then you need to support your answer using some sort of diagram. Let's go ahead and show, we're looking at B here, what 1/3 divided by 6 looks like. So we have 1/3 here. Our entire tape diagram, of course, represents one whole because we have 1, 2, 3/3. 3/3 is just a fancy way of naming one whole. So within each of our thirds, we're going to slice those into 6 pieces. I want to use different colors for our thirds and our slices just so we can see that clearly. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That chunk got a little big. We have 6 in each. Looks like it. Okay, cool. So 1/3 divided by 6. So what we're trying to figure out, when we divide 1/3 by 6, what is this slice? Well, it's 1, the denominator is 1, out of, this section was sliced into 6, this section was sliced into 6, and this section was sliced into 6. So we have 1, 2, 3 copies of 6, which is 18. So 1/3 divided by 6 is 1. Do you guys remember lesson 25? We are definitely going to have some problems from lesson 25 in our celebration of learning. We had a lot of fun with this. I think once we got warmed up, this made a lot of sense to all of us. I really loved how we really had to think about how many thirds make up a whole and how many thirds make up more than a whole. So in our celebration of learning, you are going to divide a whole number by a fraction and support that answer with a model. So let's look at and remind ourselves how we do that. So we have 3. This tape diagram represents 3 units. Within within the number 3, we have 1, 2, 3 units. That's pretty obvious. What we need to do now, however, is chop each of our units, individual units, into thirds. So you get sliced into 1, 2, 3 pieces, you get sliced into 1, 2, 3 pieces, and you get sliced into, 1, 2, 3 pieces. Sorry that these are not even. So 3 divided by 1/3, really what we're looking at is, we want to know how many slices do we have. Well, we have 1, 2, 3, 1, 2, 3, 1, 2, 3. We have 3 sets of 3, which is equal to 9. 3 divided by 1/3 is equal to 9, and then let's just go a little bit deeper here, as we did in lesson 25. This really supports our number sense. This is really good, important work, and if you guys need to use these are wonderful, wonderful strategies to help you understand or arrive at the correct final answer. So there are blank thirds and 1 whole. Well, we know there are 3 thirds and 1 whole. We know 3 thirds is just a fancy way of saying 1 whole. There are blank thirds and 3 wholes. Well, we have 3 wholes here. We are able to see that there are 9 thirds and 3 wholes. So what that means is that 9 thirds is equal to 3 wholes. Well, I know that for a fact because 9 divided by, we know that we can rewrite a fraction as a division expression. 9 divided by 3 is equal to 3. Very cool. So we're just unpacking here what you really already know. If 3 is 1/3, what is the whole? Well, this is a little bit different, but we certainly can figure this out. If 3 is 1/3, what is the whole? This is divided equally, so if 3 is 1/3, that is 3 and that is 3. Our whole would be 9. Cool. So lesson 25, a really, really good place to review for our module 4 syllabus. Okay, kiddos, lesson 30 is another great place to stop on the review train. Here in lesson 30, you guys, this was not very long ago, this was just last week. We're dividing numbers with decimals by, I guess we're dividing decimals. We'll just leave it at that. But dividing decimals can be a little tricky, so we were using the strategy of multiplying the decimal by fancy versions of 1 to shift them out of decimal land and into whole number land. And once we did that, as we can see right here, we can very easily simplify these. So we are going to see a few of these, and you can use any method, but this method that we learned in lesson 30 is really, really helpful. So let's just take a quick look at this. Let's look at 4.8 divided by 0.6, or 4 8/10 divided by 6/10. You guys know that any division expression can be rewritten as a fraction. So let's go ahead and start with that. So we have 4.8 over 0.6. These are both decimals. We're going to multiply those decimals by 10 over 10. You guys know that 10 over 10 is just a fancy version of 1. We multiply any number by 1. It's not changing the value of the number. What we're actually going to be doing is shifting these out of decimals and into whole numbers so that we can work with them a little bit more easily. So when we multiply 4.8 by 10, think about that place value chart that lives in your heart. We have a really quick place value chart here. We multiply 4.8 by 10. The digits are going to shift that away. 1 place value because there's 1, 10, and 0. So our 4 is going to go here. And our 8 is going to go here. 4.8 times 10 is 48. Now we need 0.6 times 10. Well, if we have, let's just put it here and just imagine this going out. So we have 6/10, we're going to multiply it by 10, which means 6 is going to hop over 1 place value to the left. So 0.6 times 10 is 6. So what we have here is 48 over 6, or 48 divided by 6. 48 divided by 6 is 8. because I know 6 times 8 is 48. So that lesson 32, for whatever reason, really got a few of you bent out of shape. We're just solving expressions, and then sometimes we're writing an expression based on words, or sometimes we're using words to write out, to translate an expression. Big deal. Let's look at a couple of these, okay? So here we have the product of 4 and 1/6. The product is that multiplication times 9/5. Okay, or we could say 9/5 of the product of 4 and 1/6. Let's look here. Let's write an expression here. So lesson 32, as you guys know, is also going to be in the celebration of learning. So we have 50 divided by the difference between 3/4 and 5/8. Okay, so let's slap down 3/4 and 5/8. We are looking for the difference between these two numbers, meaning we're going to use subtraction. Let's protect the difference of 3/4 and 5/8 with parentheses, and then we're going to do 50 divided by the difference of 3/4 and 5/8. So look for these key words, you guys, difference and divided by. It also might be helpful to just write your operation when we see those key words. Other key words, of course, we talked about this today. Sum is addition, you guys know this. We have, when we're looking for like a fraction of some number, that means we're going to be using multiplications, such as if we're looking for 1/2 of, that's going to be the same as 1/2 times the number. Okay, so just look for those keywords, label the operation that you're going to be using, and then just fill in your numbers. And just take those slow. Just take it one step at a time. It also might be helpful to cross out what you've written to make sure that you have written the entire expression for the phrase. We have 50 divided by the difference between, believe it or not, is kind of cousins with a problem that we're going to see in our celebration of learning. I'm not going to even do this problem right now. I think it would be great for you guys to read this, think about a plan, come in tomorrow with it solved. If you're totally stumped, come in tomorrow to class with a plan to solve it. This again is lesson 33. And it's really important that we are comfortable with a problem like this because we will see something very similar to it in our celebration of learning. We're going to be dealing with time and dividing and all things that you are very well equipped to handle. Don't forget to read the problem first. It's very helpful to organize the information into some sort of model, and then you do your calculations from there one step at a time. So this is a really good example of something we'll see on our celebration of learning. Work on it right now or after the whole video is finished. Come in with some sort of answer, and then we will go over it together and we'll talk about a few strategies that we can use to solve a problem like this. Okay, guys, we are going to look into lesson 22 for another inspiration problem. Number 5 is a really good example of something you'll see on the celebration of learning. It says, Johnny says multiplication always makes, oh, actually, you know what? It wasn't Johnny that said it. It was actually Carl, the lady hamster, that said that. Carla Lady Hamster has been traveling around the world. She has been very busy. She apologizes that she hasn't been around in math videos, but she's back. Just help you guys celebrate your learning, and she wanted to come up with a problem like this to kind of help us study. Explain to Carl. Okay, So let's read this again. Carl the lady hamster says multiplication always makes numbers bigger. Silly Carl. Explain to Carl why this isn't true. Give more than one example to help her understand. Okay, Carl. So I think what Carl's probably thinking about are examples like this. 3 times 2 equals 6. Carl, we can multiply 3 by other numbers than 2. So what happens when we multiply 3 times 1/2? Well, we get 3 over 2, which is equal to 1 and 1/2. So we went from 3 to 1 and 1/2. Okay, Carl, so you say that multiplication always makes numbers bigger, so we saw that it's not the case here. What if we're multiplying 10 times or by 1/10? Or 1/10 times 10, which you guys know, these mean the same thing. This is actually finding 1/10 of 10. So let's multiply through and see what we get, Carl. 1 times 10 is 10. On the bottom we will have a 10. That is equal to 1. So we started with a 10. We ended up with a 1. 1 is clearly smaller than 10. Carl, I love you. I think you're just such a wonderful hamster, but I'm sorry to say that multiplication does not always make numbers bigger. In the case where we're multiplying a whole number by a fraction, because really what that means, Carl, is that we're finding a fraction of a whole number, and when we're doing that, our products end up being smaller than what we started with. But I still think you're great, Carl. Are you guys going to believe me when I tell you that we're going to see some problem like lesson 1 in our celebration of learning? We are going to see a line plot. You guys are going to have to evaluate what this means. However, in our celebration of learning, the data is already going to be mapped out for you. In this lesson, we mapped the data out ourselves, or we plotted the data ourselves. So what we had to do was, I don't have the full document, so we looked at rainfall in inches from 0 to 1. And then I'm going to divide the space between 0 and 1 into eighths. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then we plotted our data. So we had 1/8 represented by an X. And then we had 1, 2, 3/8 represented by an X. 3/4 is equal to how many eighths? Well, 4 times 2 is 8. 3 times 2 is 6, so 3/4 is equal to 6/8. 1, 2, 3, 4, 5, 6. X for you. We actually have 2 3/4. We have 2 X's on top of 6/8. And then let's just say that that's a 1/4. I'm not completely sure that's a 1/4. Let's go ahead and convert that into eighths. 1/4 is actually equal to 2/8 because 4 times 2 is 8. 1 times 2 is 2. So let's plot that data. What you're going to be doing in your celebration of learning is you're going to be looking at this data. According to this line plot, we had our most frequent rainfall occur at the 6/8 marker, because we have 1, 2 data lines. And this is also just according to these data points, 1 through 5. This was the most rainfall collected in our investigation. And then the least amount of rainfall collected would be this data point down here at 1/8. So you guys are going to be looking at these data points. You're going to be thinking about what they mean. And then you're also going to be doing some conversions. It's actually a very interesting problem. You're going to be doing some conversions and I will make sure that you have all this information, with gallons, quarts, and pints. So it's an interesting problem. It's going way back to where we started in Module 4 at Lesson 1 with our data, with our line plots. And then within this, like I said, you are going to receive the data already entered or already plotted for you. You're going to analyze it, and then you're also going to do some conversions. So it's a pretty cool problem. Make sure that you're comfortable with how these data line plots work. You guys, you know that any final question in a module of learning is always a multi-step, multi-section word problem. So number 2 in lesson 33 homework is a really good example of a problem that will look vaguely familiar as the last problem in our celebration of learning. So here we have Anouk, and we're going to work on this tomorrow in class. We'll be working on lesson 33 homework and problem solving. So we have Anouk has 4.75 pounds of meat. She uses a 1/4 pound of meat to make 1 hamburger. So I have 1/4 pound. We'll make 1 hamburger drawing here. How many hamburgers can Anouk make with the meat she has? So the meat she has is 4.75. Every hamburger is going to be 1/4 of a pound. What we need to figure out is how many 1/4 of a pound live inside 4.75. And you guys know how to do this. So we will work on this tomorrow. I just wanted to give you kind of a snapshot as to what the final problem in our celebration of learning will look like. Hope you guys enjoyed the review video. Cal has snuck in here with me, so I'm going to have to sign off. Can you say bye-bye, Cal?